Yes, excellent. Well, this is going to make a lot more sense to you guys now. So Bruce is the inventor of the unlimited detail 3D rendering method for displaying unlimited point clouds data in real time, which, given the size of those data sets, is no small feat. His system consists of a compiler that takes point cloud data and converts it into compressed format, and then the engine is capable of accessing this data in such a way that it only looks at the pixels needed on the screen and ignores the rest. It's the best available way of displaying laser scanned environments, as they can be of unlimited size and it doesn't slow down your system. So Bruce, come on up.
Hello, everyone. Oh, you all look darker than usual at most conferences from here. Must be the big bright lights. I'm from Euclidean, and Euclidean is about 80 people, and we're based here in Brisbane. So we're a local technology company. Normally in 3D graphics, everything's made out of these little flat shapes called polygons. So when we look at computer games, normally you're running around really fast and you don't stop. But if you stop and you sort of have a look at the graphics, the tree there on the left is from Crysis 2, which was a popular game of a little while ago. And the tree on the right, have I got left and right? I think they're backwards on this screen, is made out of point cloud data. And that's using our technology. Now, normally with point cloud data, every point is going to cost some processor time. So a little while ago, we made the claim that we had a way of making unlimited point cloud data. So for example here, this here is a game, and it's made of 10 to 20 polygons per square meter on the ground. That's our technology. That's not 10 or 20 polygons, that's 20 million converted polygons. So we're looking at a technology here that gives 3D graphics 1 million times increase. So on the ground there, those are grains of dirt on the ground. People weren't expecting this sort of technology to exist for a very long time. Traditionally, when you build bigger Nintendos or bigger Xboxes or bigger graphics cards, you build them so your computer will be able to run more. So when we came out with this technology and said we have a way of running unlimited amounts of not polygons, but point cloud data. So with polygons, things don't look quite so round. With point cloud data, when you're actually making it out of atoms like the real world, you can make more detailed shapes. When we first began, this is what the laser scanner industry was doing. This is Faro Viewer 5 years ago. And while they're moving, they have to remove 99% of the points. And then when they stop, they put them all back. That was just to run a house. So when we said we had a new way of giving computer graphics unlimited power, some people said, let's put it to the test. Rather than scan a house, unlimited is a very big claim, let's scan an entire country. So over in Hungary, they put a laser scanner on trains, on cars, on boats, 450 terabytes. There's 1,000 gigabytes in a terabyte. They scanned as much of the capital city, now they're moving on to the rest of the country. Scanning railway stations, buildings, roads, everything they could. And we were a bit scared when they said, well, if it's unlimited, we should be able to scan our country. We went, oh, not quite that unlimited. But unlimited is unlimited. By now you must be thinking, this doesn't make any sense. How can a computer suddenly have unlimited power? We'll move on to loading in a second. Basically, this is a very different way of doing things. This is a three-dimensional search algorithm. Just like Google or Yahoo go looking for words on the internet, this goes looking for points in point cloud data. So traditionally, when I make 3D graphics out of polygons and normal point cloud data, if I put a tree on the screen and then I put a second tree, it's going to take up twice the amount of processing power. But with this, it doesn't matter if I put 1 tree, 10 trees, 1 billion trees. It very efficiently goes looking for 1 point, 1 little atom for every pixel. So there's only one cost for your screen, regardless of whatever it is you're using. It's all very well to have unlimited power, but then it takes a really, really long time to load up something like an entire country. What we're looking at here, I'm going to go back, if that works. It does. What we're looking at here is the state of Nebraska, an aerial laser scan, 60 gigabytes. It'll take about 15 to 30 minutes to load. This is our technology. We grab it there, put it there, done, 0.8 seconds. When you say loading is gone, we have abolished loading. That's a crazy claim. That's worse than unlimited power. Loading is the act of taking from the hard drive and putting into the computer's RAM. There is another way of doing this called streaming, where you use it while you take it off the hard drive. You can stream music and you can stream videos because they sort of, you use them while you pull them off the hard drive. But traditionally, people said you can't stream three-dimensional data because it needs a bit from here, a bit from here, a bit from here, and it jumps all over inside the hard drive. The hard drive opens a file and reads it and then closes it, opens the next one, reads it and closes it. So people said you cannot stream three-dimensional data. We proved this to be incorrect. In Tokyo now, they've nearly reached a petabyte of data. And the core of it is our technology. They use it for the roads and traffic authorities over there. At the moment, this technology is just passing the phase of we're working with many sort of beta test customers, and now it's about to come out to the rest of the world and be used in numerous products worldwide. The French railway system has scanned the whole railway system, and they use this technology for monitoring the entire railway system. Normally, they have to have whatever they need, 3D laser scans, in everyone's computer. But now they can put it all in one place, and they can just stream it all from that one place. I'm going to show you another piece of technology. Once you have a way of giving unlimited power and loading no longer matters, it's like jumping forward a few decades in time. You can now do things that people couldn't do beforehand. Laser scanners. I think you've heard a lot about them today. When I first heard the word laser scanner, I went, that sounds like a wonderful device. We should use it for making graphics for computer games and things like that. But then when I had a look, I went, oh, what's wrong? Well, the laser scanner makes little dots, little points. And so it doesn't, I mean, you wouldn't play a game that looked like that. This is our technology. We've made a new output for the laser scanner where it makes a skin of points rather than individual little dots. So we've now made it so laser scanners can be like 3D cameras. They can be used for copying in the real world. The problem with that is the reason why no one else did it is you'd have so much data, nothing would be able to run it. But solving the problems of loading, and there is no such thing as too much data, means that we've now moved into this technology for copying the real world. Behold the future, so they tell us. Everyone wearing Oculus Rifts and helmets and things like that. When people said, Euclidean, you've got some pretty good technology, it's being used in big places all around the world. Can you join and help with the virtual reality race? We had a look at this. There's 59 different virtual reality helmets coming out in the next 2 years. And we said, it's flooded. It's a flooded market. Let's jump over virtual reality helmets, which are screens over your eyes, and go to the other form of virtual reality that people were not expecting for a few decades. Virtual reality comes in two forms. The one is screens over your eyes on helmets. The other is hologram rooms, hologram caves, environments where you go inside and it projects objects in the environment. Monash University in Melbourne built one for about $3 million. Around the world, people have built them from anywhere from $1.5 million to $15 million. And we decided to move into this area and see if we could make a hologram room run on one computer using that same technology that can run whole cities. It was a complete success. And we were able to build hologram rooms at a fraction of the price. So that looks like a person just sort of running around some monuments. None of that is real. It's all made of light. You can put your hand straight through it. We've opened up a hologram entertainment center. Remember, hologram rooms at $3 million, normally the public would not have any chance to have any access to these devices. We've built 40 of them on the Gold Coast. We've built the world's first hologram entertainment center where people go and they jump down holes, When you jump down a hole and all the artificial atoms come up, you feel like you're falling down. You go underwater. There's all sorts of things you can do. We've just built that on the Gold Coast. We're now opening up more of them worldwide. Next year, the big thing for us is if this technology can stream so efficiently from hard drives, then it's ideal for streaming 3D graphics over the internet. Let me just speed this one along. How do I do that? So this here looks like what we saw before, except it's running over the internet without any sort of plug-in. At the moment, when you go to websites, you probably have a picture or a video. The future from now on will be real-world places, golf courses, hotel rooms, schools, all sorts of things in windows on websites that you can explore yourself. That's a technology that will be released next year. So these are just some of the things that are being made by Euclidean, a local company here in Brisbane. Thank you, everybody.
Oh, it appeals to the spatial geek and the gamer geek in me. I love it.